Hi, today we're going over section 4.7, which is modeling and solving problems with quadratic functions. Now, for word problems, we're usually looking for a vertex or an x-intercept. Most commonly, though, it will be the vertex because we'll usually be looking for a maximum or minimum value. So, for example, a store finds that if they say, oh, hoodies for $30, 600 are sold. They also found with each increase of $3, 20 less get sold. Determine which price brings in the maximum revenue and how much it is. So essentially, we know that revenue is going to equal our price times the number sold. Now, our price, we start at $30. And we're going up in increments of $3. So we'll have plus 3x, where x represents each increment. Now, number sold, we start out at 600. And for each increment, we sell 20 less. So we've got 600 minus 20x. Now, from here, we need to find our vertex because we're finding our maximum. We can do this by either foiling it out, completing the square and getting our vertex that way, or we can use our x-intercepts to get our vertex. So in this case, I think it'll probably be faster to get my vertex with my x-intercepts. Because for example, with this one, I can see that x of -10 will give me 0 for this. And 30 would give me my x-intercept of this. So for x of our vertex would be the average of those. So -10 plus 30 divided by 2, that'd be 20 over 2. So essentially our x of our vertex is 10, which means we had 10 increments of price. So we know that our price, we said, was 30 plus 3x. So we'd have 30 plus 3 times 10. So the price would be $60. Now to get our vertex, we'll take our actual equation and substitute in the x of our vertex. So we have revenue is equal to 30 plus 3x times 600 minus 20x. We'll substitute 10 in for x's, so we have 30 plus 3 times 10 times 600 minus 20 times 10. When we calculate this, we end up with $24,000. Okay, next example, two numbers have a difference of 8. Find where the sum of their squares is a minimum. So we have two numbers. So I'll say my first number is x. They have a difference of 8. So I'll say my second number is x plus 8. Now, find where the sum of their squares is a minimum. So that means we're squaring both of them. So I've got x squared plus x plus 8 squared. So we want to FOIL that out. So we've got x squared plus 8x plus 8x plus 64. We'll combine like terms. So we've got 2x squared plus 16x plus 64. This one, we also need to find a vertex. So I'll do a complete square of this one to get the vertex. So first factor out the 2. So we've got x squared plus 8x plus a blank plus 32 minus a blank. In that blank is going our b divided by 2 and squared. So we have 8 divided by 2 and squared. So 4 squared, so 16. We'll factor that perfect square trinomial we've created. So we have 2 times x plus 4 squared. And then 32 minus 16 would be 16. Foiling this out, we've got 2 times x plus 4 squared plus 32. So our vertex is -4, 32. Now, our x represented our first number. So our first number was -4. Our second number then becomes -4 plus 8, so +4. So our two numbers were -4 and +4. Next example, determine maximum rectangular area that can be fenced with 80 meters of fencing. So for this, we need to understand that the perimeter of a rectangle is 2 times our length plus 2 times our width. And we're given 80 meters of fencing is going to do that. So right off the bat, everything there is divisible by 2. So I would divide everything by 2. And then we have our area as length times width. Now, we've got 2 variables here, 2 variables here, but we can reduce that to 1 by isolating for 1 variable here. So I, for example, could move the length to the other side by subtracting it from both sides. So I have 40 minus my length gives me my width. Now, area is length times width. So we'd have length times our width, which we found was 40 minus our length. We want to find our vertex, so I'll do this one just like the first one, get my vertex from my x-intercepts. So my x-intercepts would be 0 and 40. The vertex would be 0 plus 40 divided by 2, so it would be 20. So we know that our length is equal to 20. Now we can substitute that into our width equation to get our width, which is also 20. And we can also go back to our original area equation. Area is length times 40 minus our length, substitute in our 20. So we've got 20 times 40 minus 20. So we have an area of 400 meters squared. Okay, practice work for this section starts on page 343.